So welcome. So this question says a mass is slowly and steadily lifted from a position that is 3 meters above a table to a position that is 8 meters above a table using a vertical lifting force of 4 newtons. And then what is its mass? Meaning the mass of the mass. Let's begin by visualizing. So here we have our table, and then we have a mass. And the mass as mass m, and this is 2 meters above the table, and then by the action of a vertical lifting force this mass m moves until, sorry, this is 3 meters, and this moves until it's 8 meters above the tabletop, and it's still mass m, and this was achieved using a lifting force. And this lifting force is a steady force. There's no information about it varying. And this lifting force is such that the mass moved, it says, slowly and steadily. And what it's telling me there is there's no acceleration involved here. I don't need to worry about involving acceleration. This is just the force applies. This thing moves at a nice steady speed. So I don't need to worry about extraneous physical possibilities that are not involved at this stage. So there's my visualization. So how do I solve this? And I think, as I said in a previous example, sometimes when you look at a question, there's probably there must be 20 questions at least I can ask about this kind of scenario without seeming to repeat myself. And so sometimes it's easy to get onto the wrong tack when you're doing these things and you're just thinking about it the wrong way. And I think that whenever you're not clear what to do next, it's a good idea to go back to basics. And basics for me is after I draw a diagram, I make a list of what I know and what I don't know, because that prompts me about where to go next. And what my list would look like this time is that my mass would equal, well, that's what I'm trying to find out. And my H initial would equal 3 meters, and my H final would equal 8 meters. So that actually would give me my delta H, which equals 5 meters if I needed that. Delta H is like a displacement. And then I also have a force, a lifting force in this case. It's a force, and that is 4 meters upwards. I didn't actually write it in, but this 4 newtons. I'm sorry, 4 newtons. So that would be 4 newtons. They're positive because it's going upwards. And I also know that my gravitational field strength, not my acceleration due to gravity, but my gravitational field strength is 10 newtons newtons per kilogram. For every kilogram we get 10 newtons of weight effectively. So fine, there's a list and I'm thinking, oh, look at this, I've got an F in there, I've got some kind of displacement, that's kind of telling me, oh, work is involved here, and then I've got an M and a G and some kind of displacement, so maybe that's a change in gravitational potential energy. And you go, oh, find M using, and I'm going to say, oh, my change in gravitational potential energy is equal to my work done. The work, in this case, the work energy theorem, in this case, I'd say the work gravitational potential energy theorem. And so I can expand this and say, oh, well, this is simply UG final, my potential energy final, minus my gravitational potential energy initial. And that equals, well, it's going to be my force, my displacement, and the cosine of the angle between. These are all vertically, so I know that this is going to go to 1 because the angle theta is going to be 0. So then I come down here again, I say, well, you know, this is mgh final minus mgh initial, and this is equal to my force times my displacement And then I can say, well, m times g times h final minus h initial is equal to my force multiplied by my displacement. Let's put down 1 in there so I don't forget that I did do something with the angle. And then let's start putting numbers in. So I can say m times 10 times, well, it's going to be 8, because there's my final height, minus 3, because there's my initial height, is equal to the force, which is plus 4, times my displacement. And my displacement on my diagram goes from there to there, and that is 5 meters. So that would be times 5 times 1. So then I say, well, m times 50 is equal to 20. So m is equal to 20 over 50. M is equal to 0.4 kilograms. And yeah, there it is, 0.4 kilograms. So there we have it. And we reminded ourselves of a technique, which is if you look at a question and it's not immediately obvious how you solve it, it's a really good idea to go back to some of your basic training, which is not only do you draw a diagram, but you also make a list of all the parameters that you've been given and also the parameter that you're looking for. And what I find is that most times, just the act of making that list kind of gets you thinking along the lines of the equations that you need to use. So there were hints in here saying, oh, think about work, because I had a force and a displacement. And there were hints in here saying, think about gravitational potential energy, because there was a mass and a g and a change in height. And so you can find your way through a problem that's not immediately obvious to you, how to make that first step by doing that. So there we have it.